If it was inversely proportional, then it would be 650 minus n divided by k. But because it's directly proportional, we multiply it by k. Okay. All right, so again, we have some initial conditions, but we're trying to find n of 3. Excuse me, I kind of gave what I was looking for away. But if we're finding n of 3, we have to find out what n of t is first. Well, here we actually already have a differential equation that we can use to find the general solution. In other words, we can use this to find out what n of t is, what the equation is. Okay, so I'm trying to get all the n's and dn's on the same side and t's and dt's on the same side. Remember, k is just some constant, so for this problem, I'm going to keep k with dt. So if I separate the variables, I'm going to have dn divided by 650 minus n equals k dt. Okay, so I've separated the variables. Now I'm going to integrate. The integral of dn over 650 minus n, it still involves a natural log, but think about, what do I have to take the derivative of in order to get 1 over 650 minus n? If I just have ln of the absolute value of 650 minus n, and I tried to think about the derivative of this, with ln, when I take the derivative, I get 1 over 650 minus n times negative 1, because I have a minus n, so the derivative of the inside would be negative 1. So in order to compensate for that negative 1, I have to put a negative out front of my ln. If you look at the previous problems we've done, we haven't needed a negative out front because the variable was always in front. We took the integral of 1 over y minus 2, so the derivative of y minus 2 would just be 1. Same thing here, the integral of 1 over y minus 1 was just positive ln of y minus 1, because when you take the derivative of ln, the absolute value of y minus 1, you would get 1 over y minus 1 times 1. Okay, so this time you did have to watch out for the signs. Okay, so there's my left-hand side. Then I have the integral of k with respect to t. Remember that k is just some constant. So in order for, like, what did I have to take the derivative of in order to just get that constant? I would have to have that constant times the variable. So the integral of k with respect to t is k times t plus some constant c. Okay. All right, now before I start exponentiating both sides, I'm going to go ahead and divide both sides by negative 1 to get rid of that negative. So now I have ln absolute value of 650 minus n equals negative kt minus c. Now if I exponentiate both sides, I'm going to go ahead and do the cross out of e raised to ln cancels out. So I'm just left with absolute value 650 minus n equals e to the negative kt times e to the negative c. Okay. All right. Again, e to the negative c. I'm going to call that whole new thing just c. So I'm going to go back and put subscripts on my previous c's. So now I have absolute value of 650 minus n equals ce to the negative kt. Now I'm going to drop my absolute value. So 650 minus n equals plus or minus ce to the negative kt. Like in previous problems, I'm going to call plus or minus c my new c. So put subscripts on my other ones, c sub 2, c sub 2. So now I have 650 minus n equals ce to the negative kt. Finally, move my 650 to the other side. So I'm going to end up having n equals, let's see, if I move the n over and then subtract, then I'd have 650 minus ce to the negative kt. Did I do that right? Yeah. Okay. So here's my general solution. But notice that I don't know what c is. I have to use my initial condition for that. And I also don't know what k is. K is some constant. We have to figure out what that constant is. So it's a good thing. Notice that because we have two unknowns, that's why they gave us two initial conditions, because we have to use both of them in order to figure out what they are. Okay. So let's use the first initial condition, 0, 300. And if we use that, 300 is n. So 300 equals 650 minus ce to the negative k times 0. Time is 0. Negative k times 0 is just 0. And e raised to 0 is just 1. So I'll have 300 minus 650 minus c. Sorry, this equals 300 equals 650 minus c. Therefore, if I solve for c, I get that c is equal to 350. Oh, I'm going to run out of room. It always happens. Okay, now I'm going to plug c back into this equation here. 650 minus n equals, actually, sorry, I'm going to plug it into this one, my general solution. Save us one step. So n is equal to 650 minus 350, my c value, e to the negative kt. Now my only other unknown is k. Now I'm going to use my second condition to find out what k is equal to. So in this case, n is 500. So 500 equals 650 minus 350 e to the negative k times 2. This is definitely a calculator part, but I'm going to go ahead and tell you that